string S1 and S2, return true if S2 contains a permutation of S1 or false otherwise. So what we're going to do, this is the example that is given to us, right? This is the string 1 that is given to us, AB. We should see if we can find any permutation of AB in S2. What are the permutation of AB? It's AB or BA. If we can find either of these two in S2, then we are going to return true. What do we have in S2? We have BA here, so we are going to return true. How about this case? We don't have BA or AB here, and there is a letter O in between, so that's not the right case. It's not a permutation of S1, and we are going to return false. To solve this problem, what we can do, we can assign a value to every single letter that we have. Let's say we assign 1 to A, and then we assign 2 to B, and so on. And then when we get the permutation, the summation of this permutation is going to be the same. What I mean by that is like if we assign 1 to A, so it's going to be 1 plus 2. It's going to be the same as 2 plus 1, right? We are going to get the total summation of any of these permutation is going to be equal to 3, no matter what, right? So we can use this to iterate through this S2 and see if we can get the same summation from the sliding window that we start from the beginning till the end. So what I mean by that, it's like we start iterating like through this S2, and and the sliding window is going to be equal to the size of S1. So S1 here length is equal to 2, so we are going to have a sliding windows of length 2. If we assign a value to I and assign another value to E, we are going to get a different summation than 3. And the values that we are going to assign to alphabet is not going to be the same. And then if we get the same summation, then we can say we might have the permutation of S1 in S2. Let's go through the code so you can better understand this solution. First thing first, we are going to get the length of S1 and S2, right? After doing that, we are going to deal with a special case. What is that special case? Is the length of S2 is bigger than length of S1 is bigger than S2. If S1 is bigger than S2, we know that for sure that we cannot find any permutation of S1 in S2. So we are going to say if n is bigger than m, then we can clearly return false. After dealing with this special case, what we are going to do, we are going to make a hash map of all the English alphabet letters and assign a value to it. Let's do that. We are going to build alphabet hash map. And for doing that, we are going to define a dictionary here, and we define a dictionary here, and we are going to use a for loop equal to length of the alphabet, which is going to be 26, and we are going to say hash map, and then we are going to say we are going to use ord for a, which is going to be plus I, and we are going to say I plus 1. So what we are going to do here, we are going to use alphabet as the key and I as the value. For presentation purpose, I'm going to print this hash map so you can see how it's going to look like. This is the hash map that we are using here. So just for easy understanding, I'm going to put this here. Okay, and now what we are going to do, we are going to we need to get the summation of S1, which is going to be the same as we said, like it doesn't matter what permutation, the summation of the letters is going to be the same. So we need to get the summation. We are going to have a total 1 for summation of S1, and we are going to use total do for the sliding window equal to the length of S1 that we are going through S2, right? So we are going to start the summation both from 0, and then what we are going to do, we are going to say for I in range n is the length of the strings that we have in S1. We are going to calculate the total one. Total one is going to be plus equal to Hashmap. We need to get the letter. It's going to be S1 at index I, and we get the value. So we get the value for it and we get the total one. We can also, we are going to use a sliding window, and for using a sliding window, we are going to use queue, right? Because it's very easy to work with and fast. We are going to use dequeue from collections. And we are going to make the sliding window, add the sliding window in here. So what I'm going to do, I'm going to get the total for the sliding window. We get it from S2 at index I, and then I'm going to append that S2 at index I to the queue. So for better understanding, what I'm going to do here, I'm going to write here S1 is, what do we have as S1? It's going to be AB. And S2 is going to be EID, BA, OO. And the total for this one so far is, total 1 is going to be 3. And total 1 for this one, the sliding window, is for EI, right? We are at EI. The total 2 is going to be, what is E? It's 5. What is I? It's 9. So the total is going to be 14, right? And the queue that we have, it's including E and I right now. So this is what we have so far. After doing this, we need to check the, like, as you see here, the total 3 is not equal to 14, but we need to check that, right? For every single one. So total 1, if it equal to total 2, we cannot return true here. Why? Because for special cases like this, D, the summation of AD is going to be 1 plus 4, right? 1 plus 4. And the summation of BC is going to be 2 plus 3. So the both have the same summation of 5, but they are not equal. What I can do here, I can say I need to get the hash map of the S1. How I can do that? I'm going to use the collections library. I'm going to use the counter, because this way I have the number of the letters that I have and the number of each letter that I am going to have, right? This is what I'm going to get. So I'm going to add here, count is going to be letter A, we have 1 of A, and letter B, we have 1 of B. And then I need to get the counter of values that I have in the Q2, so E and I. So I'm going to say counter of the Q that I have. If it is equal to count, then I'm going to return true. So as you see here, if I make the same counter like the dictionary for these two, it's not going to be the same. It's going to be what? It's going to be A is going to equal to 1, D is equal to 1, and then for this one, it's going to be B, and it's going to be 1C, and as you see, these are not the same. So they are not going to be equal, and we are not going to get false true. So this is the case that we have so far. Now we have done only E and I to build our sliding window. And now we need to iterate through the rest of the string. If we have true here, we are done. But if not, we are going to iterate through the rest of the string. And we start from N because we have iterated till N at index. We start from index N to the end of the S2, which has length is equal to M. What we are going to do now, we need to pop E and add D. So we are going to get to the Q. We are going to pop from left, right? we get E out, and then I add D in. Right? Now we are going to add D in. And after doing that, we need to fix total too. We need to remove the E that were added to total. So for doing that, we are going to get the value that we had for E before is going to be I minus N, which is going to be this index. It's going to be index 0. And what I'm going to do after removing that, I'm going to get the new total. Total 2 plus 1 hash map, and it's gonna be for D. It's gonna be index I. And then we are going to do the exact same thing here. But we are not supposed to copy and paste, but we do it here just to show you we are going to do exact same thing and see if they are the same. And if they are, we are going to return true. Otherwise, if none of these are true, we are going to return false. And that's about it. The time complexity for this is going to be linear, because we have to iterate over every single value that we have in this string. And the space complexity is going to be constant, because we are just adding values to the queue, and it's going to have a constant length. And that's how we solve this problem. And I just run the code, and as you see, it has been accepted. Thank you.